This proof of concept, in the context of the HORSE project, is showcasing the complete prediction workflow of an attack occurring, a DNS amplification, in a telecom network, and how it is predicted and analysed using network digital twins. The workflow starts with the early modelling, sending the attack models to the network digital twins. First, the DNS amplification model is sent to the prediction and prevention NDT with the concrete details of the attack as the module that is affected, in this case, the DNS server. Then, the early modelling sends the threat information to the impact analysis NDT, where a translation to a MSPL format is done to later emulate the attack in the NDT. This MSPL includes the concrete information needed for the deployment of the attack in the NDT: attacker, victim, duration, etc. The second step is the prediction of the attack, made by the Prediction and Prevention Network digital twin, which sends the information to the distributed and trustable AI engine. The Prediction and Prevention NDT collects live peak-up traces from the real network. We can see the type of traffic that is analysing for the prediction. As a result of this prediction, this NDT sends to the DTE the type of attack that should be mitigated and the confidence, in this case, DNS amplification with a 0.6 confidence level. The DTE receives the information and creates a new message ready to be sent to the following module. In this step, the DTE creates an intent with the information received from the Prediction and Prevention NDT and sends it to the intent-based interface. On this side, we can see how the DTE creates the intent with the information of the attack, type, duration, host, and how it is sent to the IBI. We can see in the dashboard of the IBI how appears a new intent to prevent a DNS amplification that is still not fulfilled, and the new threat that attacks the DNS server. In the last part of the workflow, the IBI interacts to the Impact Analysis Network digital twin to start the what-if loop and check the impact of the attack in the network. First, we can see that there is still no attack running, nor QoS policies or filtering in the router. When the intent arrives to the IBI, it sends to the Impact Analysis NDT a monitoring request to launch the attack in the network and check how it affects. The threat changes to under emulation state, and the NDT launches an emulation of the attack. After 30 seconds, the NDT responds to the monitoring requests with the values requested, packets per second in the interface of the router 3. After the monitor request, the IBI send a new request for applying a rate limit of 1 megabit per second in the router. We check that the QoS is applied in the router and the attack is running. After 30 seconds, the NDT sends back the response to the IBI with the values requested. As these values still are not good enough for the mitigation of the attack, the IBI sends the last request to block the attacker IP in the router interface. We check that the filtering is applied in the router interface and the attack is running. After 30 seconds, the NDT responds the request of the IBI with the value of 0, as the traffic from the attacker has been blocked. Finally, the IBI dashboard shows that the intent has been fulfilled and the attack has been mitigated.